Just, I'm advertising and I didn't mean to. Okay, here we go. Sorry. All right. Today we're going to review for the exam. This is a paper in class. Paper in class. Please make sure all your homework is done. If it is not, I'll penalize you 5 points. Homework's done. In 5.1 and 5.2 section, we talked about composite, oops, functions. Preparation for our logarithms. We said the argument we had, supposing I have h of x, is equal, and I can say either exponential or radical or rational. I can say it is f of x over the g of x, which is this portion here, or the reverse, or whatever. We're talking about the argument within the group raised to a power or to a radical, and it would be like 1/2 on this case. So we have given here that f of x is 18 over x plus 4, and g of x is 3 square roots of x. And we're saying we want f of g at 4. So it says the 4 goes into the g, right? And then from that point, we go further on. So this, on the A, we're saying that I have g of 4 inserted as an input for f. But I am. And equals the 18 over 3 square roots of 4 plus 4. And that's as bad as it gets. You're only going to get one of these. And it's from your homework. And I put down which one it is. And then our g of f of x is go at 2, means that I do the g of that and take the root of 18 over 3 square roots of x plus 4. Then the f of f, we're supposed to come back with the kind of the original in a sense. Really interesting, to say the least. And we're talking 1. So that is going to be 18 fifths for the first, and then it is 18 over 8 of this plus 4. Kind of ugly. And then we have to simplify that. And this is 5, 20. And that will give me, what is 38 is only 2, right? Because it's 19. Okay. Then we do the g of 0. G of 0 is 0, and it is 0. That one's no brainer. Okay. What did I do? Oh, it came out clean. I thought it would come. I saw a 5. Where did I get that? No, I did this one wrong too. I did, because this is an f of 1. Oh, that one was right. It's this one that I did wrong. Yeah, okay, got it. Let's do it. It's a 2, Elma. Okay, it's a 3, and it's going to be 18 over 2 plus 4, which is 3. Right? Thank you. Bad math. You're not going to do bad math. All right, so in this one, it says we're going to do the general form of the equations and then check to see if they're inverses of each other. In other words, we get x. So let's do that. So I'm going to have a -4 times a -1/4 x minus 4 to plus 4. So in this case, I'm going to have a positive x, and it's going to be, what do I have here? Plus, oh, it's a plus. Just have a plus 4 there. I wrote it wrong. Plus 4. Oh, I didn't. Oh, I'm getting myself confused. In place of this, I'm putting all of that, and I didn't do it. I did it right, and I did it wrong. It's, so sorry, guys. Sorry. This is going to be x plus a 16 plus a 4. I'm going to do the other one. Not as severely bad, but nearly bad. Sorry about that. All right, so now I'm going to do the math, and that's a positive x, -1, and that, right?
This is for -4, and then we have -1.
Oh, I have it twice, is what you're saying. Uh-huh, I sure do. I sure did. I have to put it the way it is. This x is this guy right here. And I'm sorry. Day already. So this is 0. And I got an x. So are they inverses? Are they? To determine whether the functions f are inverses of each other. And the answer is no. Because f of f and f of g should come out x's. All right. This guy is solving, and we have to change this guy to 2's. Let's see, this is going to be, what do we have here? 4 is, I'm doing 4's, and that would be 2. Right? It's 2, correct? Am I doing this right? Yeah. So this is 2, 4, 6, 7. Okay. I'm sorry, 2 to the 7. There we go. All right, because the bases are alike, then x cubed has to equal 7x, and I'm going to subtract it. So it's 0 and plus or minus the square root of 7. Okay. This guy right here, We're going to do the same thing. That's 7. Thank goodness I can just use that. Oh, 2. 2 to the 4, negative plus the 22 is 2 to the 7x. 2 to the negative 4x plus 88 equals 2 to the 7x. We're going to put in the negative 4x plus the 88. Bases are alike. The exponents must equal. Works because we don't have that negative to make it flip out. All right. Again, this one is commonality. So our first step is to make them all 2s. Okay, because it's 2 to the 4 is 16 times 2 is 8. All right. So when we multiply like bases, we add them. Now we set the exponents equal to each other. It's a quadratic. 4 and 2 minus 2x plus 4. And we have to test it to make sure that it would possibly work on this case. So if I have this value here at a negative 4, x is a negative 4, I would have a very small number. The negative will not work, only the positive. And we'll check it with a calculator, make sure. That's to the 16, isn't it? Yep. 256. Let's find out. Oops. Both of them work. Didn't think the negative would work, but it did. This is a fraction, but well, there you go. On this guy, we have like bases. We're going to have a negative 18 equals 6x, a negative 3 equals x. And this is just a fraction. That's all this is. But it's 7 times that, so yeah, I think that'll work too. And we're going to say e to, what did I say, negative 3?
Mhm.
And then I'm going to have e to the negative 21 plus 18. Tell from looking at it that it was going to work. It's just a fraction. Okay, on this guy, find the exact without using a calculator. That means we need the same bases. So we're going to say log base 9 of 9 squared, right? So the 2 is the outcome is always an exponent of like bases. On this guy here, we're going to change it to 3s. And we get our solution. 3 or 3, Elma. That was a 3. Okay, that one was cool. Nothing hard. Exact answers without a calculator. Again, we're looking at the square root of 8. So we're going to first rewrite it. Is that true? Yes. Find the exact value without using a calculator on a natural log. So this one's kind of tricky, but it's not. So we're going to rewrite it as e to 1 over 11. Okay, so ln and e are inverses. This one is a calculator. This one's not an issue here. Just stick it in. Again, looking at where the keys are. And it's approximate, and I'll tell you how many decimal places. We're going to do 4 for scientists today. On the test, it'll tell you how many decimals. It says use a calculator. Again, this is telling you that this has to be in parentheses, then divided by this has to be a negative. So, like I said, this is not a difficult one. But I don't know. This is over 1. The natural log is over 1. All right. So we're going to say it's going to be approximately, we're going to do 4 decimal places. Well, 3 on that one because it's a 0. All right. Now, this one is using properties, and the properties is if we multiply, we add them if we extend them. If it's division, we subtract them. And the log base is the only thing that'll upset you on this one, that you forget, like your instructor does, drop what the base is. And simplifying. Simplifying will get us as well. So we want to make sure that we would write it as the log base 6 of 1,296 plus the log base 6 of x. And let's do that guy. Right? And 216 is also 6. No, yeah? Maybe? 6 is 1846. Yeah. We can do 6, and that will give us 3 is 1836 is 9, right? But 39 is not 6. Oh, wait. I can't do math. Nobody caught me. Thank God. So, 6. Okay. So this is going to be log base 6 of 6 to the 1, 2, 3, 4. Sure I did that correctly. So plus log base 6 of x. So that makes it 4 plus log base 6 of x. This one is power rule. The power rule says I can write it as 7 log base 5 of z. This is product. So we're going to first extend it. Natural log of e plus natural log of x. This is 1. Because the exponent is 1. How we doing? Anything off the wall? Okay. All right, this guy right here. Come on. Uh-oh, I might be running out of juice on this thing. Oh, no, good. All right, this one is the equation, logarithmic equation. So what we're going to do is we're going to put it equal to 0. So that means I have log base 6 of x plus 2 minus log base 6 of 8 equals 0. Now I'm going to condense it. So that'll be log base 6 of x plus 2 divided by 8 equals 0. Correct? So I have 6 to the 0, which is 1. So I can say x plus 2 over 8 equals 1. Because this is 6 to the 0 is 1. Right? Yes. Yes? Okay. Plus 2 equals 8. X is 6. And what would we do after we do that? We check it. Yes. Thank you. We will.
Since they have the same base,
Oh, and I didn't even think about that.
could
You did a short, and I was just doing the rules. Yes, but I want to check, make sure I'm okay. Thank you for that. Okay, so we want to go math all the way to, where is that thing? Log base. And I'm going to enter 6. And I'm going to do the whole thing. So I'm going to do, what did I say it was? 6? Yeah. Oh, it's 8 divided by 8. Yeah, it's good. I don't have to do it. True, you said. And they want an equation on this guy. So the first thing is I'm going to say log 6 of x minus 8 squared plus log 6 of 9 equals 2. I'm going to write it as a multiplication. Log base 6 of 9 times x minus 8 squared equals 2, isn't it? Okay, so now I'm going to have 9 times x, turning it into an exponential, 6 squared. 9x minus 8 to the 36. X minus 8 equals 4. X is 12. All right. Questions on that? And 12 doesn't make ugly things happen there, so we're good. All right. Now on this guy right here, we have to do the division because there's no, and it's a base 10 because there's not a base mentioned. Very important. So I'm going to write it as 1. Now I'm going to convert it to an exponential. That would make it 10 equals. I'm going to cross multiply. $10x minus that 50 equals that. Okay, I'm going to subtract 7. I'm going to add 50. Subtract by 3. I'm just going to have to make it so. It won't go even. Questions on that? This one, that one was a base 10. This next And so we're going to take care of that. Sorry. Yeah. Let me write small. Log base 3, and it's a product rule. All right, I'm going to convert it. Oh, sorry about that. Okay, now I have to do FOIL because I'm going to have a quadratic. Sorry about that, guys. So it's going to be x squared plus 12x plus 20 equals 9. Does everybody agree? All right. I'm going to subtract 9. That makes it 21. This is going to be, well, I'm sorry, can't do math. I apologize. Don't get me. Hold on. It's been a day. Just been a day. It's 11 and 1. I stayed up too late, maybe. I don't know. Okay. So in both cases, one may not work. This one definitely works. It might not. We don't know. It's a -1 here. And I don't think it'll work. Let's try it. We can always check with our handy dandy calculator. And it's a change of base. So we're going to do math and go all the way down. And we'll enter the 3. And then we're going to go, we want, what did I say it was? A -1? Yeah, okay. No, the -1's not an issue. 11, yeah. And that would make it a -11 plus 10. All I need to do is check if that exists. And it doesn't. The product of an exponent is not negative. So the only solution is this guy. Okay, remember you have your tool. Please check. I don't expect you to know all of it. You've got a tool. All right, this is compounding. We did it 2 ways. We did it first by formula, remember? And then we did it by app. So and you can have your notes for calculator with you for the test, but you cannot have the calculator notes, not your notes. Okay, is everybody comfortable with that? Everybody good? Okay, all right. So we'll work on this. Here we go. On this one, we have A equals P times 1 plus R divided by N raised to the NT. And it's also on your information sheet, so it's not anything that you have to memorize. Okay, so in this case, what principle needed now? So we're looking at P. Get the given amount. We want, given the amount, which is 600. Oops. After 3 years, 5%. That information is also on that calculator sheet. This is just a tool to use in your future. Okay? All right. So I'm going to have 600 equals the P1 plus 0.05 divided by 12 raised to the 12 times the 3. And this is on the home screen, whichever way you want to go. So I'm going to have, I'm going to divide both sides by that exponent. That's 36. I'll just write 36. And I'm going to get approximately, money is in 2 decimals. Everybody get that? Now we're going to go to our app. 12 times 3. No problem. I said I was taking a shortcut on that. Solver, and I'm going to type in 12 times the 3. I'm going to do the percent as it's written. The present value was 0. Payment is 0. Future value we know is 600. Our PY and CY are 12. We up to the present value and do an alpha in them. And there's the answer. Whichever route you go is okay with me. Everybody follow along? And I have to stop. I think I'm out of time. All right, I'll finish this up when we come back.